Hi, my name is CADCAM and I am the CNC lead for Westlake this year. In this presentation, I'll be going over what the CNC is, just a general overview of it, and what to be aware of when you're using it. The CNC stands for Computer Numerical Control, and it's the automated control of a machine. A CNC system can be used for most machines like the lathe or the mill, but the one we refer to as the CNC in the shop and the one we're going to talk about today is the computer-controlled mill. The CNC usually cuts out of flat pieces of stock, whether it be various thicknesses of wood, plastic, or metal. Here at Westlake, we also recently added an attachment to one of our machines that allows us to cut metal 2x2 tubing, which is a type of stock that is commonly used on the mill. The CNC team's machining process starts with designers giving us a CAD file of the part they'd like to cut. We then convert this into a CAM file, which is a file that holds all the G-code the machine uses. The way we convert from CAD to CAM files is through a program known as HSMworks. It's a free plugin to Solidworks, and it's the easiest way to convert the files. It's a relatively easy skill to learn, and it's a good skill to pick up regardless if you are a manufacturer or a designer. It only takes a couple minutes to convert the files. However, it's easy to overlook any mistakes during this process, and it's important to have a final look over before you start machining. This is an example of what a CAD-CAM converted file would look like in SolidWorks after you converted the file. As you can see, we use a lot of contours and bores in the operations to cut out the holes and the overall piece itself. After we have our converted file, the next step is to set up the stock we will cut out of. When we set up the stock, the main priority is to stop the CNC drill bit from moving the stock. It has a surprising amount of power, so we use several things to hold down our parts. We use double-sided tape on the back of the stock, clamps, and weights. The CAM part file will be put into the computer through a USB that holds all of the CAM files. When you pull the part up on the computer, you then use the origin that you set in your CAM file to set a point on the stock in real life. This point will serve as a reference for the machine when it's cutting out parts, and it's essentially 0, for the G-code coordinate system. When we set the real-life origin, we set the X and Y axes. Since different materials have different thicknesses, we also set a Z-axis. This will help the CNC know where it started and how deep into the material it can go. There are two ways we use to set the Z-axis: the puck, which is shown in the picture, and using paper. These two methods of setting the Z-axis is something that you will go more into if you actually want to learn how to use the CNC. After all the setting up, all that's left to do is to run the part and cut it out. After you do this, the part will come out likely with some sharp edges which can cut skin. To prevent any injuries, we use a deburr tool, which is shown in the picture, that allows us to clean up and shave away any sharp edges. After all the deburring, the part is done and can be handed off to the designers to use.